your notes, then automatically you'll be able to answer. And definitely, practical practice is needed simultaneously. All right. So I'll start presenting the screen. Is it
Is it
visible?
visible?
All right.
All right.
Okay.
Oh,
So
so
let's go
let's
to
go
my.
to my.
So let
So
us
let us
check.
check.
As I told you, some tools are there which are very, very much used. Okay, everyday basis you are going to use those. So I'll start with those tools and gradually I will go to the less used tools. Okay, but to be very honest, all the tools are equally important because it is going to solve your problem maybe in a very crucial time. So it is always better to know. I'm going to the mesh tool and okay, before that, let's take a primitive. So I have taken a cube and I will also try to explain the difference between the tools. So first of all, I'm going to insert edge loop tool. Okay, insert edge loop tool. Here it is, insert edge loop tool. So what the insert edge loop tool will do, just check. If I select this and I do some modification in a vertex, I can change the shape of this primitive, isn't it? I can change the shape. But what I want to change in between somewhere of this cube. So for that, what we do generally, we need more vertices, isn't it? You already know. In curve you have done. You need to edit some of the areas, you need a vertex over there. So I'm going to insert edge loop tool and clicking on the edge. Can you see? We have created an edge loop. Okay, we have created an edge loop. So similarly this edge we can create, right? Edge loops. And it will follow the entire surface. Now what? I can select this and I can give it a shape. All right. Maybe this side also if I want. Understood? So this is insert edge loop tool. Once again I will show how I am drawing insert edge loop tool. Insert edge loop tool and you have to click on the edge. Okay, you want a loop. This loop was horizontal. I want a vertical loop like this. So you need to click on this edge. You will get it vertically and you can see the entire surface. You are getting the loop. So this is a loop. Okay, not one edge, this is a loop. Is that clear? Insert edge loop tool. Is that clear? All right. Okay, so if there is a short note, okay, on insert edge loop tool. So insert edge loop tool is a tool we can use on polygonal primitives. So this will be the first answer, first sentence of your answer. And then we can create a loop according to the topology of the object. According to the topology of the object. This sentence you can write it down, later on you will forget. we can create an edge loop. We can create an edge loop. We can create an edge loop according to the according to the topology. Topology. According to the topology of the object. Right. Now you can ask me, sir, what is this topology? Okay, topology. This is a very important term in modeling, topology. So just imagine, in NURBS you already have made a flower vase, isn't it? All of you almost, I guess, made a flower vase. Now it is circular. The flower vase is circular. So a circular object, you have seen that you have used so many circles to make it, isn't it? So all the isopumps you have created while creating a flower vase, that means what? All right. So the base proportion is incorrect in this. I need to rectify it. Anyway, so if I check the isopump, can you see wherever you will create this isopump, this is circular. This is circular, right? So in this case, all these are all topology. These are called topology. Okay, this mesh is called topology, and in this side, the topology is like this, and this is these are all very beautiful curves. How beautiful your curve is, that much beautiful your object will be. Okay, so these are all together is called topology. Understood? Now, in the case of this, okay, so these loops are the topology of this particular cube. The house you are sitting right now, all of you are sitting inside the house right now. How the topology should be if you are modeling that house? The topology should be like this because it is a cubic shape house. So whatever mesh you are going to create, it will be cubic shape like this. This will be the topology. Understood? Suppose an object is there that is of, suppose you are making a tube and that is of S curve. How the topology should be? Topology also should be S curve. You are making a tube like a C. So the topology also should be like a C. Are you getting my point? Are you getting my point, guys? Because this is very important. Okay, all right. So that was topology. So we were looking at, yeah, we were looking at insert edge loop tool. Now you will understand. Now when I am using insert edge loop tool, Can you see? It is working according to the topology of this object, because this is a cubic object. So all squares we will get in the topology, right? Any side you will give, or you will insert an edge loop, it will be a square. So that is the topology of this. And a single click, just check over here. I am creating a loop and I am creating a history over there. And this is the input history we are creating. So when we'll delete the history, all of this history will go and file size you are going to reduce like this. Okay, when all the history is there in your file, then file size will be bigger. When you are deleting all the history of all the objects, then automatically your file size will be reduced. I guess this was fine, right? Insert edge loop tool, we have seen it worked according to the topology. Now if you are using a previous version of Maya, there will be something called cut faces tool. Okay, in my from my 2017, that particular tool is not there. Okay, cut faces tool, it used to be in Maya. Now in that we are having one tool that is called multi cut tool. Okay, there used to be two different tools. Okay, one was cut faces tool, one was split polygon tool. Both tools are not there. So in my 2017, what they did, they created a single tool which is having both the tools, split polygon tool and cut faces tool, and that's how they named it multi cut tool. Okay, you have to remember multi cut tool. What it does, it can work like a split polygon tool. So I'm clicking from here to there randomly. Let's check and pressing enter. What's happening? I have created an edge and now I can modify it. Okay, so I can split like this, but it is not working according to the topology. No, it is not working. And so can I create a loop? So loop also definitely can be created out of this. Press enter. So this is a loop. So it is not very regular. This square is not very regular, not according to the topology. But yes, we can create like this by splitting. And can you see? We can insert also edge loop. So how I am getting it? I am holding control in a keyboard. Okay, holding control, you can create a loop according to the topology. So inside the multi-cut tool, everything is there. So insert edge loop tool is also there inside this tool. So cut faces tool, split polygon tool, and insert edge loop tool. All the three tools are there inside this one tool, and that is called multi-cut tool. That's how the name is, multi-cut tool. All right. Now everything is fine. Now you can ask, where is the cut now? Okay. Now it works according to the camera. Just check. From here, I'm dragging the tool up to there. Can you see? So it created a cut mark according to the camera, but not according to the topology. So this is not topology. What's happening right now? So this is basically cut faces tool. This is the job of cut faces tool. But now we can do it through multi-cut tool. Is that fine? I will show this once again. Suppose this corner I want to cut. Okay, suppose this corner, this corner. Okay, so this is multi-cut tool, very important tool. In our modeling, we are going to use these two tools, insert edge loop tool and multi-cut tool, again and again. Okay, so I'm going to the custom. I'm holding Control Shift once again. Uh, we already have seen it, how to insert tools inside the shelf. So once again, I'm going to do it. Control Shift, and let's keep insert edge loop tool and multi-cut tool in the shelf. Okay. Now moving forward, I'm taking the insert edge loop tool and giving a loop. And then you realized, no, I wanted this loop a little bit this side. So what can be done? I'm going to mesh tool, and there is something called slide edge tool. What it does, slide edge tool. See, it was showing you what you need to do. Just come once again. Slide edge. Can you see? Drag with middle mouse button to slide. It was written like that. So through middle mouse button, just drag. It will be dragged, and it will be dragged according to the topology. So you don't have to be worried. Just check. I will. I can give a better idea. Let's keep it like this, right? And let's insert an edge loop. All right. And going to slide edge. Double click on it. Single click just to select one edge and drag it. See, shape is not changed. Can you see this? Shape is not changed. Slide edge tool. And if you were double clicking on it, so enter loop will be selected, and see the shape is not changed. But at the same time, if you want to move it, the shape is changed. Understood? The job of slide edge tool. Slide edge tool. You need to remember. We can slide an edge loop like this. Okay. Now, okay, I'm keeping this tool also over here. Very much used. All these three tools very much used. Okay, coming to the next tool, and that is called offset edge loop tool. Okay, offset edge loop tool. So this is already one edge loop. I
Sir,
want two edge loops, both the, yes.
sir, while slide edge
Who is
tool
that?
we control and shift. Sir, Sagar.
No, it was written no in the viewport, middle mouse button and drag. Middle mouse button and drag.
Yes, sir.
Hmm?
Yes, yes.
Yeah. Okay. So this is offset edge loop tool. Can you see both the sides of one edge loop? You can create two edge loops like this. So some cases may come like this. You want two edge loops at the similar distance, both the sides can come like this. Okay. So this is offset edge loop tool. So like this. So suppose you were giving two edge loops like this, and you want more. So like this, like this, like this, like this, like this. Can you see? So both the sides. Very difficult to give manually like this. Okay. So offset edge loop tool. This is also very much helpful. Not always, but sometimes. Generally, I prefer to give manual edge loops, not with um, some tools or something. This tool will work for everything. Anyway, got the idea, right? So then, okay, some very important tools are there. All right. So suppose this is the model. Okay. I'm creating a house. Suppose I'm coming to the faces and I'm creating the faces because I want to create windows, right? So I need to delete some faces. And by chance, I deleted two faces from here also. By chance, I wanted to delete this to create a house because I wanted to create windows, and I created this also. Can you see how easy the polygonal modeling is than the NURB surfaces? And I think this is also one reason why people use polygon more than NURBS, because NURB surface is a little bit tricky. You have to be very precise, but in polygon, it is artistic freedom is there in polygon. Anyway, so now what was the problem? I wanted to create the window, and by chance I deleted this also. So I want to fill this now. So how to fill it? So just select the object. This time I'm not going to mesh tool, but going to mesh. Okay, going to mesh, and we are having one option called fill hole. Fill hole. Okay, so just click on fill hole. Okay, but you know what? We didn't get the lines, and the window is also closed. That is the problem. I wanted the window. In that case, you just select it and delete it once again, and this portion is done. So just split from here to there. Okay, now the mesh is all right. There is no problem in the mesh, but I don't want this lengthy process. It is looking too lengthy. First fill it. Sometimes it will be very easy for you to use this fill hole, but in this case there can be several windows, no, and there can be a small region I made this error. So in that case, what I'm going to do, again going to the mesh tool, and there is one option called append to polygon. Append to polygon. Okay, append to polygon. So first we have seen insert edge loop, then we saw multi-cut, then we saw slide edge, and now I'm coming to append to polygon. All right, append to polygon. So taking the tool, append to polygon, check it very carefully. Clicking on an edge. Okay, now select the next edge, select the next edge, and press enter. So this face has been created. Once again going to append, similar way. So only that much area is done for me. Understood difference between fill hole and append to polygon tool? Fill hole is filling all the holes in a surface, but append to polygon tool, it is creating new faces from edge to edge. Okay, that is append to polygon tool. Now I will show you how it is different. Suppose append to polygon tool, from here to there also you can create an edge. Let me delete it. Let's delete this also. How it can be helpful, I'm showing. And you want to bridge this area. Okay, so in that case, append to polygon, from here this edge to this edge, and press enter. Can you see how beautiful it is? All right. So append to polygon. You need to remember. And the difference between fill hole and append to polygon. Fill hole, the all the holes in the surface will be filled in a fill hole. And append to polygon tool, only in the append to polygon tool, we can create faces from edge to edge. Before that also what we did, that was edge to edge. So now I want to fill this area. So sorry, make sure you are selecting correctly. Now there is a problem because there is no division. So the next stage will be like this. So what I did, still I selected the edge. So whatever surface I created, edge to edge. You need to remember this. We create faces edge to edge in the append to polygon tool. In fill hole, all the holes can be filled out of fill hole. Now another thing is there in the fill hole. Okay, I'm just showing you the possibilities. I'm selecting the edges of this hole, around this hole. I'm going to mesh and fill hole. Can you see what was my problem? Actually, I wanted to fill only one hole. It is done. So this also can be done from the fill hole. That is the reason I'm telling you want to fill any particular hole or all the holes. We are going to use fill hole. If we want to create a face from one edge to the other edge, we are going to use append to polygon tool. But you know what? Most of the cases in the modeling, append to polygon tool will be used than fill hole tool. Okay, you will understand later on the reason behind it. That is the reason. Don't ignore append to polygon tool. Very, very important. Tell me, all of you understood this? All right. Okay, mesh. Mesh means the wireframe you can see on that model, the sky line, sky blue line, that is called mesh. Okay. The same thing is called topology. The same thing is called mesh. The same thing is called wireframe. Okay. So if you are modeling something and I told you, okay, your mesh is incorrect, what you should understand, that the alignment of these lines are incorrect. So that is mesh. Okay, fine. Now let's come to another tool is there that is also very important. That is called create polygon tool. Okay, create polygon tool. So we are not using this tool on a primitive, but create polygon tool, by the name only you can understand, you can create some shape out of it. So can you see, I don't know what is this, but enter. So I created a plane out of it, and this is a random plane. But if you ask me, so this is a face, you can see these are all edges, so this is a polygonal surface. And If you check it very carefully, inside loops are not there, isn't it? So this, in terms of a surface, this surface is incorrect because last day we discussed in polygonal modeling all the faces should be in quads. Can you remember this? I told you that for now just remember this first rule, that all the faces should be in quads. Can you remember, guys? Can you remember this? All the faces should be in quads. And then somebody asked me, what is a quad? Okay, one person can remember. Hmm. So quad is a face which is having, yes, Sagaras, correct. So quad is a face which is having four vertices. Okay, that is one quad. So that we discussed last day. Once again, I am telling you, in polygonal modeling, all the faces should be in quads. But if you count this face, so we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 vertices. Okay, so this face is actually incorrect. We need to convert it into quads. So, but you know what? I need this shape only because whatever I am going to create, I need this shape. So I'm going to multi-cut tool. Now you need to learn how to use multiple tools. So I'm taking multi-cut tool, splitting it. Okay. So I got one quad, second quad, third quad, fourth quad. Okay, these are all correct now. Now this area and this area is incorrect still. So let us check what can be done for this area. That's fine. So this is a quad, this is a quad, but this is not a quad because here I can see one vertex. So from here, let's split. So now these are all quads, all quads. Now this area is incorrect. Okay. Now these are all quads. Now this surface is correct. Okay. So you select individual faces. These are having only four vertices, not more than that. That is the rule. The face should not have more than four vertices. Even you cannot keep a triangle. It has to be a quad only. Not triangle, nor pentagon, nor hexagon. It should be a quad only. All of you got my point? Okay. Hmm. All right. All right. QUAD, quad.
Sir, I didn't understand the quads.
Quad you didn't understand?
Yes, sir.
Select this face. Going to the vertex. How many vertices this face is containing? One, two, three, four. So this face is called a quad. Okay. So now take this face. One, two, three, four. So this face is called a quad. Take this one. One, two, three, four. So this face is a quad. Now you understood?
Yes, sir.
All right. Now this is an object. Okay. So I don't know what is this, but if suppose you are creating something out of create polygon tool. So actually what I was showing create polygon tool. Okay. So this was the tool create polygon tool. Delete. All right. Now let's come to the most important tool. Most important tool. And that is called now going to the edit mesh option. Okay. Edit mesh. Generally, the tools we have seen mostly used tools. Some more tools are there. Gradually, I will come back to those. But for now, I'm going to the edit mesh tool. Means the polygons we are going to edit now. So the very first tool I am going. Let me check where they have kept it because all the versions they change the position. So here it is. Okay, components, and the first tool is extrude. So in knobs also we had extrude, in polygon also we are having extrude. Okay, so you should not select the model and extrude, you should not do that. So always remember, while extruding you need to select a face you want to extrude. Okay, you want to select a face and extrude. So we got the extrude tool now in this case. So you can see the knobs extrusion was a little bit different than polygonal extrusion. But the same thing is happening in polygon extrude means we are increasing the polygon. Okay, I'll just undo it. Can you see this is called the poly count. This is called in the viewport is called the poly count. Can you see in the viewport how many vertices I am using now? I'm using 8 vertices. How many edges? 12 edges. How many faces? 6 faces. How many triangles? 12 triangles. And UVs? 14 UVs I am using. Okay, so whatever in a scene, suppose in a scene 2 objects are there. So this is the overall value in a viewport, and whatever is selected over here it will come. Okay, so in this case both are same actually. So you can see now I am using 6 faces. I just wanted to show this 6 faces. All right, now let's select the face, going to edit mesh and extrude. Now how many faces I am using? 10 faces. So I have increased it. That's why I was telling you that extrude means we are increasing the polygon. Okay, we are increasing the polygon. So what we can do, this is called manipulated tool. Manipulated tool. So in this case, just check. If I pull it, what's happening? 4 faces I have increased. That's why it is written 10 now. Okay, so like this, I can pull like this. These boxes are there. Just select any. You can scale it to the same tool, and at the same time just click on the circle. You can rotate it after extrusion, just after extrusion you can do all these things. Okay, So in the extrusion, what we do generally, we increase the polygons. In this case, actually, one face is one polygon. Okay. So if uh, in the production you are making a model and somebody is asking you, how many polygons have you used? So that can refer 2 points: how many faces you have used, or how many triangles you have used. So this is obvious, no? How many faces? The triangle will be just the double of the faces, because one quad contains two triangles. Okay. And in the manipulator, we can translate, we can rotate, we can scale the face. Okay, so this is basically the extrusion. Now this is not all. Now coming to the complicated part of the extrusion. So previously I have done the extrusion only by using one face. This time I'm selecting both the faces and let's extrude it. Okay, this is the positive Z direction. Can you see? Positive Z direction. I'm pulling it this side, but how come this face is going towards the negative Z? I guess you were getting my point, what I'm trying to say. If I am pulling the faces towards the positive Z, why is it going towards the negative Z? It should not be. Once again, let us check. Let's rotate it. In the scale, positive X scaling. Okay, directly. I'm just rotating it. In this case, it is scaled proper. It is. I have given the rotation properly, but how come it is happening like that? Can you see? Both the faces are working separately. I'm moving it downward, that is going upward. It is behaving just the opposite. So there is some problem. Okay, this is called the local axis. Whatever I am doing now, this is called local axis. Because of the local axis, it is happening like that. So whatever we see in the manipulator, this is the local axis of this face, but the local axis is of this face is totally different, and that's why it is behaving differently. Now how it can behave like the same? Can you see a small dotted circle over here, sky shape? I'm clicking on it. Now it is a global axis. So the axis we see over here and this axis are the same. Pulling towards the positive Z, it is coming towards the positive Z, and this is also coming towards the positive Z. Anyway, I can see some distortion in the model, but just ignore that for now. Try to understand what's happening. Coming towards the positive Z, coming towards the positive Z. This is fine. Now what if I want this face to be this side, that face to be that side? I need to scale it because it is behaving as one object, this face and this face. Going down, going up. Understood? So this axis is called whatever axis at the middle. Just check. It is at the middle, not over here. Previously, the pivot point over was over here. Okay, this is called global axis. So in extrusion, there will be two different axes. One will be global axis, one will be local axis. Local axis, individual components we are going to work with. Global axis, it will act like a single object. All the components will act like a single object. Tell me, is that okay? All of you understood? Hmm. Okay, these are all very shy yes, that yes, yes, I understood. I think I understood that these yes are like that. Okay, I'm sure still some problems are there. See, one second I'm going to do. I'm selecting both the faces, okay, and extruding it, right, and pushing it downward, okay, pushing it downward, but that is going upward because this is a local axis. The pivot point of this and the arrangement of this manipulator and the arrangement of this manipulator is different. So in this case, then I'm actually pushing in the negative y-axis. No, for this phase, the negative y-axis is upward. That is the local axis of this phase. Okay, this is the reason it is happening like that. But if I click over here, it will be converted into global axis. Now you just push it, both the faces will go down. So that is the global axis. In the global axis, all the components will work together. In local axis, it will work individually. Now tell me, you understood? All right. This is actually very simple. Okay. Today, for the first time, it is looking a little bit confusing. Once you will actually work practically, but whatever example I took, no, took a primitive, then select both the side faces, and then tried extrude. You need to practice this. Okay, very important. Make sure you are practicing this. All right.
Sir,
Is that
sir Sagar,
yes, Sagar? Tell me.
sir, if you want to extrude one surface, one face,
Then doesn't matter. Then doesn't matter, no?
okay,
Yeah, because because means so many cases it will happen like the local axis and global axis are the same. Understood? So if you are selecting only one face, then the local axis and global axis, you will find so many cases it will be same. So it will not create any problem. Now let's make it more complicated. Okay. Now selecting this and selecting this, and I'm extruding it. Let me do something. Control Shift and extrude. So because this is very often means everyday basis we are going to use these four tools. All right. So let's extrude. I'm extruding it. Before some time I did. All right. Now select this one and extrude. Sagar, can you see? It doesn't matter if it is a single face.
yes sir, yes sir.
Now selecting this, see, y-axis is sleeping, but actually globally y-axis always will be standing. So this is the local axis. You by looking at it, you can understand. Okay. Now I want to create a pattern. Now I will show you what is the benefit of using local axis. In the beginning, you will feel like why they have even given local axis. It is so confusing. Now I will show you the benefit of the local axis. Select this and select this. I want to create a pattern for all these three faces. So what I am going to do, I have now selected three faces and extrude. Let us check where the local axis is. Okay, all right. I want to scale it down. So if I select global axis, have you seen how I have changed the global axis by selecting on it? Now it is global axis, okay? Now if I scale it down, it is going inside. It is going that side, it is going that side because it is behaving like a single object. I don't want that. I want to scale it down at its own position. So I'll just undo it and let's go back to the local axis and just scale it down. Okay, very nice. It is scaling at its own position. Understood the benefit of the local axis? It has been done, it has also been done at its own position. This is the local axis.
Sir, but it should be in opposite direction.
Sorry?
It goes opposite. मतलब सर opposite में जाता है ना?
No, 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 no. Don't remember like that. Local axis always will work in a local position. Remember like that. Okay, local axis always will work in the local position. It will not count all the components together. But in global axis, what happened before some time, I was scaling down, it was calculating all the components as one object. And in this case, that was a problem. In the previous example, we needed that. But in this case, we don't want that. So now the same thing, once again, I'm going to do. Now selecting these faces, okay? Again extrude. And this time, I want to push it. See, this side, I will push it inside. In that case also, it it actually goes opposite side, but I wanted the result like that. So in this case, I am going to use local axis. Okay, so whatever, this pattern in this pattern looking the same. Now in polygonal modeling, you have to remember this. If you press one, you will see polygons like individual faces like this. If you press two, the bounding box, and after smoothing how the model will look, that preview you can see. And if you press 3, the smooth model you can see. So can you see what actually I was modeling? I was modeling a toy spaceship. This is a toy, right? So your visualization is very important. What is your visualization? And according, after you know smoothing it, what you are going to get your model, that will be totally different. Now, if you feel like, okay, I am feeling like this one, I want to push it a little bit more inside. Okay, this and this also, I want to push a little bit more inside. Okay, this, how is it? Okay, it is looking a little bit better. Okay, tell me, you are getting my point? Hmm. This time it shows you understood. All right. So, don't you think it is very interesting? The polygonal modeling is very interesting, and very quickly you can get a result. You don't have to analyze too much. It is very artist friendly. Polygonal surfaces. You just uh, need to Visualize the surface inside your brain, and then automatically you can execute it. Going back to mine. So I will request all of you to model this. Okay, whatever I have modeled. Now I will model a second object. First, I am keeping the primitive like this, and width and depth, let's make it one by one. So I wanted a cross loop like this. Now let's go to mesh tool. So whatever we have learned, I'll try to use those only. Okay. And offset edge loop, if you can remember offset edge loop. Before some time I did. Okay. And this side also I'm using offset edge loop. All right. Now let's select the corner faces. You understood why I needed these edge loops? Just to select the faces of these. Okay. One second extrude. Okay. In the local axis only. I'm just pulling it down here. What is this? What is this? Tell me. Yes. Yes. So this is a table. Okay, and you can see how quickly we can create objects out of polygon. Yes. Now this table is very fragile until unless the in-between bridge is there. Okay. So what can be done? I need more edge loops in between. So giving edge loops like this, you know, very difficult to understand if I have created at the same height. Okay. So coming to the front view or coming to the side view, whatever, if you can remember, I used cut faces. I'm holding shift to make a straight line. So done for all the legs. See how simple? Cut faces tool. Actually, in this case, multi cut tool. Generally, we previous version we used to use cut faces tool. In this case, multi cut tool. Okay. Now, how to connect it? So you are going to learn a few more. I'm selecting this face. I'm selecting this face. I have selected both the faces and extrude, and let's bring it together. Now these are very close, and I will just delete the internal faces that is not needed. Okay, and then selecting this vertex and this vertex. Now I want to combine it. Okay, those two vertices. So what I'm going to do, I'm going to edit mesh, and yes, here it is. Merge to center. Merge to center. Okay, can you see? It has been merged at the center. Now selecting these two, I'm pressing G. G is the last used command. Selecting these two, G. Selecting these two and G. So the bridge is ready. There is no problem. Tell me, is that clear? All right. So what we did, merge. You have to remember that, merge. So extruded from both the sides and merge. Now you can tell me that, sir, don't you think this is a little bit lengthy process? My answer will be yes, it is a lengthy process. So what can be done? I'm selecting this face. I'm selecting this face. I have selected both the faces. I'm going to edit mesh, and there is another option called bridge. Okay, I'm going to the option box and make sure that divisions are 0 and bridge it. See how simple it is, quick. Okay, selecting this and this, bridge. Selecting this and this, bridge. And the table is done for us. And this is the polygonal model. Polygonal model always will be single object, as we discussed. Single object. Nerve surfaces will be in a group. That is the reason NURBS modeling is also called patch modeling, because so many small patches will be there. The same NURBS modeling is called patch modeling. You have to remember this, because sometimes in the exam it comes like write a short note on NURBS modeling, and sometimes it can be write a short note on patch modeling. Then you will think like, sir didn't teach us patch modeling. Sir only taught us, NURBS modeling and polygonal modeling. You have to remember, NURBS modeling is called patch modeling. So don't be confused in this. So if necessary, just write it down. Write a short note on NURBS modeling slash patch modeling. So all of you just write it down. No, no, slash means line, sliding line. Yes, sliding line. Okay, guys, got my point. All right. So now what I am expecting, I have showed you that toy. I showed you. Quest means Prajakta. Quest means okay. Okay. Question. Um, Question was, write a short note on nerves modeling, or what I told, patch modeling. Write a short note on nerves modeling or patch modeling. Both are same. I meant to say that both are same. Okay. All right. So today, what we have done basically, we have done the toy. That toy is very important. That is the basic object you can create out of extrude. So very good object to practice extrude. Okay. So all of you needs to do it. That toy. And the second object is table. I already showed you how to make the table. Now you have to create also a third object, and that will be a chair. Yes, that will be a chair. I will not show you how to make the chair right now. First you will do it, and then I will show you how to make the chair. But first you people will make the chair. Okay, so first one is toy, table, and chair. Yes, yes. You people need to create these three objects. Is that fine? All of you can do it? All right, very good. Sagar, first you make what I showed today. Okay? All right, very good. Okay, I told you. Okay, anybody uh, succeeded creating umbrella and spring? All right. Anybody successfully done? Any of you successfully done? Okay, very good. Then I would like to see. Okay, so who will present first? Vijay, yes, all right.